Hi, folks. This is Dr. Kat Schreier, Water Citizen News. Be in the know with your mojo. I am here with how do you pronounce it?
Dabkowski.
Bob Dabkowski from Hach. Tell us about your innovation. We're here at the Innovation Pavilion. You can hear them presenting in the background at WEFTEC in New Orleans. And we're talking with some of the folks who are coming up with some innovative technologies, including not just the smaller startups, but also some of the larger companies that are doing what's called entrepreneurship, folks who are innovating from the inside. So that would be you. What's your role at Hach, and what are you doing that's entrepreneurial?
So I'm in the applications group at Hach, which basically means I get to try out everything first. I'm a licensed wastewater operator. I've been with Hach 15 years. And my focus with Hach is all around process control, automation, and giving operators a better view of the process, helping them do their job easier, quicker, faster, better.
And so we've got a lot of folks here who are, water citizens, are interested in water. They may not have a technical background in water. So what are the kinds of things that you all do with water, and how might someone without a water background understand it?
Sure. Hach started as a company that made very simple test kits back in 1949. And as the industry has evolved and as operators have asked for better testing methods and sensors that measure 24/7, we've also evolved to create those sensors. Now we're evolving to fill a new operator demand, what we're calling real-time control. In essence, operators asking us to automate a certain process. For example, automate polymer dosing in front of sludge thickening equipment or in front of sludge dewatering equipment, or automating a chemical feed for phosphorus removal, automating aeration for nitrification. All of those are applications within the real-time controller platform. Here specifically in the Innovation Forum, we were speaking about polymer dosing for dewatering thickening applications, as we're looking for partners to help us innovate and help us apply and learn ultimately how we can improve those processes and improve the product.
So operators are talking about the water utilities, wastewater utilities, the people who are treating drinking water and wastewater.
Right, the frontline citizens that give us clean water day in, day out.
Right. And so these are sludge, and these are different processes for treating the water. So when you talk about real time, I mean, is this the kind of thing that somebody's going to be able to pull up their smartphone and yes, this is a BlackBerry, and say, look, this is what my system looks like here?
It's more specific than that, where it's going to be, they are systems in plant, right? So on a transmitter, on a display, next to, say, a gravity belt thickener, helping to control that polymer dose. We can certainly map them into wireless technology. That's not a problem. Most operators today don't want that quite yet. They're very happy to have the application streamlined, so it makes their job easier on site, and then they can turn it over to the next operator when their shift is over.
So what might be the advantages of having real-time response? I mean, is this for disasters? Is this when do you want to be able to have that sort of capability?
Boy, I hope not disasters, but that's, I think, what we're trying to avoid are disasters. Whenever an operator has the ability to see what's happening in the process, that process gets better. So if nothing else, if they put in a sensor that measures one thing or another, they're going to improve that process based on that sensor. When they put real-time control involved, they're taking the data from that sensor and they're using it to adjust something else. So for example, adjusting a pump that's dosing a chemical. Well, before, the operator maybe would take a grab sample once a shift and adjust the pump once a shift. Now we're doing that thousands of times per shift without the operator having to be there to adjust that pump up and down. So what we're doing is trying to take some work that they're already doing, make it more efficient, and free them up to do other tasks. But at the same time, we understand that balance is here. Whenever you automate a process, the operator still needs to know how to operate that process. Because if there is a catastrophe, they're going to need to know how to fix it. And so with the real-time control systems providing not just the automation, but also the transparency, the amount of understanding that you see in an operator goes from one level to a whole new level. And when that system does need to go offline and they need to go into manual mode, they understand what they need to do. It's amazing to watch. Operators are very physical, hands-on people. And so when you can present data and you can present that process to them in a very physical and real way, their understanding goes through the roof.
So those operators, those people on the front lines of water, wastewater systems, really critical to have that technology in their hands. Now you did mention a particular site that you tested this with, and that where was that?
So the one we presented today was at Thames Water in the UK.
Okay, so people go to London, they're looking at the River Thames.
That's right.
London Bridge, falling down into into the River Thames. So why was it important for River Thames? How did they use this?
Yeah, so piloted there was the sludge thickening control system. So controlling the polymer dose going into these systems that are called rotary drum thickeners. Think about a washing machine, like a front loader. Same concept, except feed it with sludge instead of laundry. And on the back side, the thick sludge falls out and the water falls through the holes, right? Well, you need to feed a little polymer to make that work. And so at Thames, they feed polymer, but they take a grab sample once a day, determine what the polymer dose should be, and leave it at that setting. We're using sensors measure every second to determine what the polymer really should be right now, not just once a day, but once a second. And so in that case, we saw them reduce their polymer use by 35%. It was significant because the sludge load varied so much.
What's the advantage of reducing the polymer?
Yeah, wow. So one of the big advantages is obviously cost savings, right? Polymer is not cheap, and it's certainly not getting any less expensive. So reducing polymer budgets is one. But second is when you overfeed a chemical, it's kind of like putting too much oil in your car. You're going to have problems. There's maintenance problems that go with that. And so there's a host of maintenance problems that get avoided because you're not overfeeding chemical. So those are some of the big benefits we've seen.
Nice. Yeah. Well, it sounds like a great technology that could be some huge benefits for utilities. And thank you very much for taking time to talk to Water Citizen and all our folks out here on the internet. Be in the know and the mojo. Thanks for coming, guys.